Hi, mathematicians. This is Ms. Shopper. We're starting to talk about Unit 9.1, reflections. Chapter 9 is all about transformations and symmetry. So let's not waste any time. Let's get started. So a line of reflection is a line that something is reflected over, right? And so you've talked about reflections, you've talked about translations, you've talked about rotations. So we're going to continue on that discussion and then just take you a little bit further, okay? Just so that you know, the pre-image is designated as A prime is noted as the image. So the pre-image is what you start with, the image is what you end with. If you have a pre-image and then your image, the line of symmetry is perpendicular. It's going to be perpendicular, whoops, right here, to the line that connects those 2 points, okay? So understanding that that is perpendicular is going to be important, all right? The point is not on the line is perpendicular to the it's a perpendicular bisector, I should have added that, to the segment joining those 2 points. All right. So when we're taking a look at these figures, draw the reflected image of the quadrilateral in line M. Okay, so basically what we have here is we want to figure out which one is a reflection, okay, using line M, and the answer is going to be this one, all right? So when we have like this line of, see how your B's connect, your C's connect, your D's connect, and your A's connect? They connect at right angles. But when you look here, these also connect. These are also at right angles as well. This is not at a right angle, right? You see the difference between those? And here it might look like the C's are, but the B's certainly aren't, and the D's certainly aren't, right? So this one is reflected. A is slid. It's a translation, but C is the one that is reflected. It is reflected. All right, quadrilateral JKLM has the vertices. Graph the image. Well, we have the pre-image. We want to graph the image, okay? So I'm going to change to green. All right. So if I'm reflecting it over x equals 1, so we drew in x equals 1. So when I do this, M is one space to the left of it, so M prime is going to be one step to the right of it. J is one step to the right of it. J prime is going to be one step to the left of it. K is 2 steps to the right of it, so K prime is going to be 2 steps to the left of it. L is 1 step to the right of it. L prime is going to be 1 step to the left of it. And so when I draw my figure, this is what it looks like. That's what the reflection looks like. Okay. All right. Here's another example. Only this time we're going to reflect it over the line y equals -2. This is a really good example of like remembering how horizontal lines are graphed and how vertical lines are graphed. So this horizontal line is y equals -2. So what we're going to do is we're going to do the same exact thing. K is 1, 2, 3, 4 lines above. So it's going to go 1, 2, 3, 4 lines below K prime. L is 1 above. So L prime is 1 below. J is 1, 2, 3, 4, 5 above. So we're going to go 1, 2, 3, 4, 5 below. And M is 1, 2, 3 above. So we're going to go 1, 2, 3 below. All right. So when you're dealing with reflecting over a horizontal and vertical line, all right, we're just counting. Nothing fancy. Okay. Nothing fancy. And so these are some rules that you can use. Just, you know, instead of counting, if you want to do it algebraically, what you're doing, if you're going to reflect it over the x-axis, the x will stay the same, the y becomes the opposite. And that's what we were seeing in that first example. With the second example, we're reflecting over a y-axis. So y equals -2 or -3. So your y stays the same and your x changes to its opposite. All right. So when we're looking at that, that's what we're looking at. Okay. So reflecting in the x-axis, reflecting in the y-axis. When you reflect in the x-axis, your y value changes. When you reflect in the y-axis, your x value changes. All right. So we have this graphed here. And we want to graph its image when it's reflected on the x-axis. So here's my x-axis. I'm going to reflect it. So on my x-axis, oops, maybe I should do the x-axis instead of the y. My apologies. Here is the x-axis. All right. So what we're going to do is we can just draw it. 1 above to 1 below, 2 above to 2 below, 1 below to 1 above, 3 below to 3 above. Okay, so we can totally do it that way. If you want to do it, let me get this labeled. If you want to do it algebraically, when you reflect over the x-axis, your y value takes on the opposite. So A prime is going to be x stays the same at 1. The y becomes -1. For B prime, the x stays the same. We take the opposite of y. For C prime, 4 stays the same. Take the opposite of y. D prime, keep x the same. Opposite 3 is 3. So you can do it either way. All right. We take the opposite of the y when reflecting over an x-axis. Right. Here's another example. We're going to graph it with the vertices. It's there and reflect its image on the y-axis. So here's the y-axis. All right. A is 1 to the right, going 1 to the left. B is 3 to the right. We're going to make it to 3 to the left. C is 1, 2, 3, 4 to the right. We're going to go 1, 2, 3, 4 to the left. D is 2 to the right, 2 to the left. There we go. All right. Same thing. Again, algebraically, if you're going over the y-axis, your x value takes the opposite. The y value stays the same. The x value takes the opposite. The y value stays the same. All right. The x value changes. The y stays the same. Now, here's where it gets a little bit different. We're going to be reflecting it over the equation y equals x. So just a reminder that y equals x goes through the origin and has a rise of 1 and a run of 1. So that's what the equation y equals x looks for. When we are going to reflect an ordered pair over that, here is the rule for that. When you reflect it over that diagonal line, you're going to switch your x and your y values, right? So here we begin with B as the preimage. B prime switches the x and y value. A preimage, preimage of A prime is switching those values. So when we look at this particular example, all right, so reflecting over the x-axis, the y value changes. Over the y-axis, the x value changes. Reflecting it over the line y equals x, the x and y switch spots. Switch, switch, switch. Okay, so let's take a look at that. All right, so if I want to do it algebraically, they're going to switch spots. Oh, look at that. 1, 1. That doesn't even move. It stays as A prime. If I go to B prime, I switch spots. It now becomes 2, 3. So I go over 2, up 3. There's B prime. C prime, 4, -1 now becomes -1, 4. -1, 1, 2, 3, 4. That's C prime. And D prime, switch to -3, we'll switch to -3, 2. We flip-flop the x and y. When we reflect it over the equation, y equals x. So -3, 2, and there's D. Right? There you go. So this is just a review of what we talked about, what each of the different rules are, whether you're reflecting over the x, the y-axis, or the equation y equals x. All right? So you can get started on your assignment, and we will answer questions in class. Take care. Bye.